Good morning, students. Last class we ended with the topic using Oersted experiment. So that experiment is basic for to explain about electromagnets. And what is electromagnet? We discussed electric current passing through the conductor. Magnetic field is producing around that conductor. This magnetic field due to the electric current passing through the conductor, this combination is called as electromagnet. How to confirm that? How he did to confirm producing a magnetic field around the current carrying conductor or near to the current carrying conductor? He kept magnetic compass needle. This compass needle shows the reflection when the electric current passing through the conductor. Then he confirmed, and also when the direction of the current changes in that conductor, that time the magnetic needle also showing the reflection in opposite as compared to the previous one. This is the experiment I studied. Also along with the experiment we discussed about example. Then we discussed about application of hysteresis loop. So what is hysteresis loop? So hysteresis mean the loop which is used to show the hysteresis in diagram, and we can compare the hysteresis between the two or more materials. For comparing we are using that diagram, that graph. Hysteresis means we know magnetic field is lags behind the magnetizing field, that we know very well. Okay, that everything discussed in earlier previous classes. So after I asked the experiment, they elaborate the experiment and they got more ideas about the electromagnet, and they will develop in future, they will use in many cases. Now we'll see the what is the basic experiment after the IST experiment. That is 3.7.2 magnetic field around a straight current carrying conductor and a circular loop. So these two we are going to discuss. So what is the topic? Magnetic field around a straight current carrying conductor and circular loop. So first we will discuss about current carrying straight conductor. So what happens there? How to prove that? That we'll discuss. Then after that, discuss about the circular coil, and this is experiment to prove how the electromagnet are producing in the straight conductor. And see the figure 3.26. A and B two pictures are given. See the A, that golden color copper wire is inserted through that. So for this experiment we can explain with a simple project. So first I will explain that project that is not given in your book. If you understand that project, if you understand that activity which you studied in 10th standard, it's easy to understand this topic also. So first we'll discuss that. So once again I am clearing you. This explanation, this activity what I am going to explain is not given in your 12th standard. But if you understand that, it will be easy for this answer. We are taking cardboard. This cardboard is kept parallel to the earth surface, or it is clamped. The stand is horizontally. This cardboard is made with single hole at mid portion, and through that hole we are having a straight current carrying conductor or copper wire, and the two ends of the copper is connected to the positive and negative of the battery. Next, around that hole on this cardboard, the iron filings will be spread over that with a non-uniform manner. Then we are passing the electric current through the conductor. After passing the electric current, we have to tap that cardboard because of small tap. Keep in your mind, there is not a huge tap. The small tap is given on the cardboard. So due to the tap, due to the small vibration, all the iron filings will arrange themselves as a circle or spherical in shape around the current carrying conductor. So why this spherical? Why the iron filings are arranged themselves as spherical? This is the question here. So we know naturally the iron filings are attracted by the magnetic field. So the electric current is flowing through the conductor, magnetic field is produces there. This magnetic field is arranging the ion filings in a uniform manner. So now it is clear, we can say the current carrying straight wire surrounded that, it producing the magnetic field, that we can confirm that. This is the experiment we discussed as activity in 10th standard. And now in this straight wire was explained with a compass needle. So straight wire, electric current is passing through that, so it's called as current carrying conductor. When we are keeping near to the current carrying conductor, we are keeping the compass needle near to the current carrying conductor. This compass needle is showing the reflection. This reflection is due to the magnetic field which is produced by the current carrying conductor. So when we are reversing the electric current through the conductor, at the time the reflection of the compass is also reversed. So that is explained here. The current reverses, the magnetic poles also changing. At the same time, when we are giving strength of the current is more, the magnetic field surrounded this conductor is also more. So it is clear, it is clearly explained in figure 3.26a. The photocopy is given. Then 3.26b, it is explained. The current is acting, and here the magnetic lines direction is acting like a anti-clockwise direction. Suppose the electric current direction is reversed in this conductor, means the magnetic field direction is also reversed as the clockwise direction. That is explained here for the current carrying straight conductor. Our next topic is circular coil which is carrying the current. So last case we explained with the straight wire, and here is circular coil carrying current. And for that the picture is given figure 3.27. Two figures are given, A and B. See, the A is photograph, and same we can explain like 10th activity. A cardboard, on that cardboard two holes are there, so like the picture A, and on the through the two holes we have taken the lengthy single copper wire. It is changing into the shape like a circular loop. The two ends will be connected to the battery positive and negative terminal. So at the top of this cardboard, it is non-uniformly distributed with the ion filings. When we are passing the electric current through the copper wire, we are giving the small tap. That small tap arranging the ion filings as a concentric circles. So near to the copper wire, then near to the hole, it is arranged very more number of ion filings because of maximum magnetic field. When we are going away from that wire, there are a lot of gap because of the less magnetic field. And like this it is made here, what the diagram shown. See here in this one hole, so that there is a circle of the ion filings, and in next hole also the same thing is happened. So here the magnetic field is produces, here also is produces due to the passing electric current. And at the mid portion it is almost straight because both the side magnetic field is influencing this mid portion, mid area, that is explained in this photograph. And next, see in B, the explanation is given. The magnetic field is more strength near to the wire, and when we are going away, the strength is decreases. Same time, we can explain the more electric current is passing through the conductor, the more strength of the magnetic field is produces. So that is explained. So in last case, how we explained for current carrying straight wire, like that same we can explain for circular coil. The only the difference, that wire is straight, here the straight wire is bent into the circle format. Then we are doing the experiment. So these two experiments mainly are used to explain how the electric current is producing magnetic field when the electric current passing through that. So that is explained here with the ion filings. And in 12th standard they explain with the help of compass needle. So when we are keeping near to the copper wire or any type of conducting wire, when it is passing with the current, That compass needle shows the deflection. This deflection is due to the magnetic field. And when we are reversing the current, you know what is reversing the current? Positive terminal will be replaced with the negative. The negative now as positive. When we are reversing that, the reflection of the compass needle is also reverse or opposite direction. So it is more clear. The point is electric current passing through the conductor, there is a production of the magnetic field around the current carrying conductor. So that was explained using these two cases. So hope you understood about these two concepts. ஸோ ஆல்ரெடி நான் சொன்ன மாதிரி எந்த ஆன்சரையும் மக்கப் பண்ணி எழுத வேணாம். ஜஸ்ட் யூ அண்டர்ஸ்டாண்ட். ஸோ மக்கப் பண்ணுற வேல்யூஸ் ஃபார்முலாஸ் மட்டும் மக்கப் பண்ணிக்கோ. ஸோ மேக்ஸிமம் கான்செப்ட்ஸை யூ அண்டர்ஸ்டாண்ட் தென் ரைட் பை யுவர் ஓன், பட் மீனிங் ஷுட் நெவர் சேஞ்ச். ஓகே, ஜஸ்ட் ஒரு ரிமெம்பர் வேண்டியதாக சொன்னால், ஒரு ரீகால் பண்ணுறதுக்கு வேண்டியதாக சொன்னேன். அண்ட் த ஆன்சர் வில் ஸ்டார்ட்ஸ் ஃப்ரம் கரண்ட் கேரிங் கண்டக்டர் ஃப்ரம் ஏ பாயிண்ட் till end of this diagram. So both the cases A and B combined together as a 5-mark question. So question, explain the magnetic field around a straight current carrying conductor and a circular loop. So ரொம்ப simple answer. நான் சொன்னதெல்லாம் மைண்டில் வச்சுக்கிட்டு you can write by your own without changing the meaning of this answer. என்ன கான்செப்ட் என்ன மீனிங்கில் கொடுத்துருக்கோம் அதை மீன் சேஞ்ச் பண்ணாமல் you can write your own with the diagrams. So diagram draw பண்ணும்போது this one enough, then in the second B enough. So in the photograph is not compulsory. Okay, so you mark as 5-mark question both that. And next is right hand thumb rule. So right hand thumb rule na உடனே நம்ம lower classல படிச்ச Fleming's left hand right hand rule தான் ஞாபகம் வரும். அதே மாதிரி இந்த ரூலும். So what is given we'll discuss here. So why we are using this right hand thumb rule ன்றதை இப்போ பார்க்க போறோம். And see here, this is the expression for right hand thumb rule. And this right hand thumb rule is very easy definition, and this definition is used to show the direction of magnetic field. If we know the direction of electric current, so how to know the direction of electric current? With the help of positive and negative terminal. So the electric current is always flows from positive and towards negative. அது நமக்கு நல்லாவே தெரியும். So using that concept, if you know the direction of current, we can share the magnetic field in that conductor when the electric current flowing through that. அப்போ electricity passes, magnetic field produces. இந்த ரெண்டு கான்செப்டையும் கம்பைன் பண்ணி இந்த explanation கொடுத்துருக்காங்க. That is called as right hand thumb rule. And see the right hand rule. So in this நம்ம என்ன பண்ணுறோன்னா 4 ஃபிங்கர்ஸையும் see the picture 3.28, இங்கே 4 ஃபிங்கர்ஸ் எப்படி மடிச்சிருக்கான்னு பாருங்கள். அதே மாதிரி நம்ம கரண்ட் கேரிங் கண்டக்டர் வந்து நம்ம கையில் போகிற மாதிரி கன்சிடர் பண்ணிக்கிறோம். தென் 4 fingers are curled like this. We are extending the thumb. Thumb பார்த்தோன்னா மற்ற 4 ஃபிங்கர்ஸுக்கும் பர்பெண்டிகுலராக இருக்குது. அதுக்கு வேண்டி நம்ம கரண்ட் கேரிங் ஒயரை கையில் பிடிச்சிட்டு இருக்க மாட்டோம். ஓகே, இட் இஸ் டூ டேஞ்சரஸ். ஜஸ்ட் நம்ம அஸ்யூம் பண்ணிக்கிறோம் கரண்ட் வந்து இந்த டைரெக்ஷனில் போகிற மாதிரி. யாராவது போயிட்டு பேட்டரியில் கனெக்ஷன் பண்ணி கண்டக்டரை கைக்குள்ளே வச்சிடாதீங்க. Okay, just for assumption. And now the electric current is flowing through the conductor and thumb showing the direction of electric current. Then we can say how the 4 fingers point. It shows what direction it shows. These 4 fingers showing the direction of magnetic field. This is the answer for this right hand thumb rule. Understood? So in this right hand rule, so in this answer for right hand thumb rule, we can say we are holding the 4 fingers like a figure 3.28a figure. Then these 4 fingers are curling and all the 4 fingers are parallel to each other. Then the thumb is extended, it is perpendicular to that. Now we are considering the current is flowing in the direction of thumb direction as like a figure A. Now these 4 fingers showing the direction of magnetic field, and this answer is called as right hand thumb rule. Okay, இந்த ஆன்சரை மார்க் பண்ணி இது இம்பார்ட்டன்ட் 2 மார்க் கொஸ்டின். அண்ட் ஆல்சோ நிறையா கேசஸில் நிறையா டீட்டெயில் கொஷினில் இந்த கான்செப்டை நம்ம யூஸ் பண்ணியிருக்கோம். ஓகே, ஆன்சர் ஃப்ரம் வி ஹோல்ட் த கரண்ட் கேரிங் அப் டு ஹியர். ஓகே, திஸ் இஸ் 2 மார்க் கொஷின். டிஃபைன் ரைட் ஹேண்ட் தம் ரூல். ஓகே, ஹவ் யூ மார்க்டு திஸ்? எஸ். அண்ட் நெக்ஸ்ட் வில் சி Maxwell's right hand corkscrew rule. So just now we discussed about right hand thumb rule. இப்போ right hand corkscrew rule எப்படி explain பண்ணுறதை நம்ம பார்க்க போகிறோம். And this corkscrew, right hand corkscrew, is used to explain with the help of screwdriver. Okay, screwdriver rotate பண்ணுறதை வச்சு தான் இதை நம்ம explain பண்ணியிருக்கோம். And for that the diagram is given very clearly, figure 3.29, and see there is a screw. இந்த screw நம்ம எல்லாருமே பார்த்துருப்போம்னு நினைக்கிறேன். ஸோ இந்த ஸ்க்ரூவை நம்ம ஸ்க்ரூ டிரைவரை வச்சு ட்ரைவ் பண்ணுறோம். ஸோ ட்ரைவ் பண்ணும்போது திஸ் ஸ்க்ரூ வில் மூவ் ஃபார்வர்ட் டைரக்ஷனும். நம்ம ஸ்க்ரூ வந்து ஒரு வுட்டுக்குள்ளேயோ இல்லை ஒரு ஃபர்னிச்சர் இல்லை ஒரு வால்லையோ உள்ளே ட்ரைவ் பண்ணிட்டுருக்கோம். ஒரு டூ வீலர் ஏதோ ஒரு கனெக்ஷனில் உள்ளே ட்ரைவ் பண்ணிகிட்ருக்கோம். ஸோ வாட் இஸ் த டைரக்ஷன் ஆஃப் த ஸ்க்ரூ? நம்ம டைரக்ஷன் ஸ்க்ரூ எப்படி மூவ் ஆகுது? இன் ஃபார்வர்ட் டைரக்ஷன். அதை நம்ம கரண்ட்டாக எடுத்துக்கிட்டோன்னா the direction given by the screwdriver and the head rotate பண்ணும்ல, that direction will be taken as magnetic field. That's it. This is called as Maxwell right hand corkscrew rule. Okay, using the screw, we are driving the screw. So after driving the screw, this screw is moving in forward direction. That will be considered with the direction of the electric current. Then how this head of the screw is rotated with the screwdriver, it is the direction of the head of the screw will be taken as direction of the magnetic field. So what is this? This is called as Maxwell's right hand corkscrew rule. And in the answer you can mark from this, you can mark this answer from here. If you rotate, appo in the Maxwell right hand corkscrew rule is used to give the direction of magnetic field. So ரெண்டு கேஸ் நம்ம பார்த்துருக்கோம். ஸோ ஃபஸ்ட் ஒன் இஸ் ரைட் ஹேண்ட் தம் ரூல். அதுவும் எக்ஸ்பிளைன் பண்ணுது. நம்ம 4 ஃபிங்கர்ஸை ஹோல்டு பண்ணிவிட்டு தம்பை எக்ஸ்பேண்ட் பண்ணி அதை 4 ஃபிங்கர்ஸ்க்கு போப்பனில் எக்ஸ்பேண்ட் பண்ணி வி எக்ஸ்பிளைன்டு தட் ஆல்சோ கிவிங் த டைரக்ஷன் ஆஃப் மேக்னெட்டிக் ஃபீல்ட். இந்த மேக்ஸ்வெல்ஸ் ரைட் ஹேண்ட் கார்க்ஸ்க்ரூ ரூல்லையும் கரண்ட் டைரக்ஷனையும் ரொட்டேட் பண்ணுற அந்த ஹெட் ஆஃப் த ஸ்க்ரூ டைரக்ஷனை வச்சு வி ஆர் கிவிங் த magnetic field direction. So these two rules are used to give the direction of magnetic field when the current carrying conductor which is carrying with the current. அப்போ கரண்ட்டும் magnetic fieldum electromagnetism produce ஆகும்போது relate ஆகும்போது we are using these two rules to give the direction of that. And we'll stop our class up to this Maxwell's right hand corkscrew rule, and rest of the topic we'll discuss in next class. And for today's homework, you mark the question what we studied for straight conductor, the current carrying straight conductor, circular loop, how it producing the magnetic field around the straight conductor and circular loop. We mark no at beginning. So from here you mark no on 5 mark question up to this diagram. Okay, so this question you can take, you can mark as today's homework. So in the concept first diagram nalla thorough pannite analyze pannite, then you study that answer, then the answer will be more and more easy. So after thorough this answer, without seeing that, you write in your homework note, then you take that as photograph, send to me to my personal window. Okay, and rest of the topic we will discuss in next class. Thank you, children.